for this week you have 3 labs, but you only have to do 2 of them. So the first lab is the floating lab. So we're looking at different properties of water. So those properties are salinity. If something is more salty, it fills in the gaps between the water molecules. And because there's more stuff between the water molecules, it is a greater density. So remember, density is how much stuff in a given space. And so if there's more stuff, then you have more density. So we can measure that by creating something that floats in water. It could be anything that floats, a beach ball, whatever, but we don't have swimming pools, but we do have cups of water. So we're gonna make something that floats out of a straw. So in the science world, they call these hydrometers. And what they use these for, they get really elaborate, and they're not made out of plastic and clay. They're made out of glass tubes, and they use them for wineries, like home breweries, making alcohol, pickling, checking your swimming pools, any kind of food production that deals with a liquid, they use hydrometers. And it's just a form of quality control. So where it floats tells you what kind of stuff might be in your liquid, but we're gonna do it with this. So right here, you guys are gonna create, make it so they can see, it's floating freely in this water. Can you guys see that? And so I'm gonna count how many tick marks above the water it is, and you wanna estimate to the 10th. So it's 1, 2, 3, and a little bit more. So like it's kind of in the middle. So maybe 3 and 3.4 tick marks. So that's for normal water. If I make it a little saltier, so I dissolved some salt in here. It was about a teaspoon of salt. If I make it a little saltier and I put it in, it seems like it floats at exactly the same spot. So 1, 2, 3, and a little bit more. But if I make it really salty, we might be able to see some change. So this one has more salt, and this one, I hope you can see, is floating just a titch higher than the others. So 1, 2, 3, and it's more like 3.7 in this case. So I wanted you guys to test this out. Can you do me up here? So, and get some data. Try it yourself. See if you can get some good data on this. The more concentrated your solution, the better it is. So some ways to troubleshoot. Try to use the narrowest cup you have in your house. Try to make it as concentrated as possible. I have increments of teaspoons, but you can do more than that if you want. Just change the units for me in the table. But because this one is a lab where it's hard to see the degrees of change, I also put together another lab you can do. So this one is called the pressure lab. So if you're not seeing any change here, what you're supposed to see is the more stuff you put in, the more force is pushed up, making your hydrometer float higher in the saltier water. That's what you're supposed to see. If you tried it and you're like, yeah, it's not working for me, you can try this lab. So I'm gonna make 4 holes with a pinhole. You guys could use anything at home, but I'm using a thumbtack. And I'm kind of wiggling it around there to make a good hole. And what we're gonna do here is we're gonna see how pressure varies with height. So imagine this is your lake, and I wanna know where, for that lake, I should build the dam the strongest. So we'll know where the dam should be the strongest when we see where the most force is. So I got my 4 holes vertically, and I'm gonna fill it full of water. This one's the furthest, second furthest, not very far, and this one up here is just dripping. So down here, the molecules are denser because they're pushed closer together. Up here, the molecules are more spaced apart, because they don't have as much gravity compacting them together. Okay. Lab I was gonna have you do is the one on water flows. So you're gonna be making currents with this pipette. So if I get some, you're gonna do 4 different changes and I can't remember which is which, but I'm gonna get some fresh water in my pipette. So this has fresh water, and I'm gonna put it into some salty water. And when I put it into the salty water, I'm gonna watch where it goes. And I can see clearly, you guys probably can't see it on the video, but I can see clearly where that water is going when I pipette it slowly. And it doesn't matter if I do it at the top or at the bottom, I can see where that fresh water is going in that salty water. So if I have, like the Mississippi, a freshwater river running into a salty Gulf of Mexico ocean, I know where that water is gonna go no matter where it hits. Hopefully you can see where it goes. So you're gonna figure that part out. I'm not gonna tell you. All right, vice versa. If I put some salty water, so this is like the Dolores River or the San Juan River. So if I put some salty water into a freshwater lake like Lake Powell, where's that salty water gonna go? Well, it doesn't matter where you move your pipette, you're gonna see the flow all the same inside of the water. So if I have a salt, all right, so if you wanna see it a little better, so here I have some colder water. You can see that cold water. Even if I put it down here, it's gonna stay down. And if I put it up here, it's gonna drop down. So cold water has a tendency to go down. Right. So for extra credit this week, you guys can create a Cartesian diver. So what Cartesian divers are it's just a device, and there's lots of ways you can make them, that just barely floats in water when you fill it up. If it doesn't just barely float in water, it's not gonna work. So how do you get it to just barely float? Well, you can add more clay at the bottom, or you can add more paper clips on the bottom. So here I have a ketchup bag, and I just put a couple paper clips on it to where it's just barely floating, so when I squeeze it, it sinks down. And when I let go, it floats up. So what's happening here, this is important. What's happening here is the air inside the ketchup bag, when I add pressure, it gets compressed because air is easily compressed. That's why we have air compressors. So that air inside the ketchup bag is squishing together and it's taking less space. And because it's squishing together and taking less space, it becomes more dense and it sinks. When I let it go, well, now that air can take more space again, and so it's like a balloon. It blows back up and then it floats up to the top. Here I made it, you could do it with a straw and a rubber band and paper clips hanging on that, or I just cut the pipette that you guys used in lab and I put clay on the bottom to act as a weight. And I played around with how much water I put in it to begin with, but there is air in it too. Can you see there has to be a little bit of air for it to work. So when I squeeze on the bottle, again, it's compressing the air inside, and that's why it sinks. When I let go, the air takes up more space and it goes back to the top. So this is under pressure, and so that pressure is making that air compress, and this is when there's no pressure. So that's your extra credit. You just build one, take a picture of it, show your parents something, get them to sign off, and you